Welcome to the today's topic. Our topic is rule-based classification. Myself Priyanka Gupta. I am working as assistant professor in Department of Computer Science and Engineering Data Science at Institute of Aeronautical Engineering, Hyderabad. Today I am going to discuss about what is basically rule-based classifiers, how we are going to write the rules, if else rules, and what are the important terminologies and points are there to remember. Apart from that, we are going to discuss the rule extraction from a decision tree, as well as we will see what are the different advantages of rule-based classifier. So the classification is used here for rule-based classifier, right? So the term rule-based classification can be used to refer to any classification scheme that is going to make the if-else rules. If then rules will be there for to do the classification for the class levels, for class prediction. So we can express a rule in the following manner. How we are going to write the rule, if then rule. First, if we will write if, then condition, syntax will be like that. Then we will write then. These are the keywords, if and then. Sometimes we'll use and. So these are the actually keyword there, right? So we are going to use that. One, two, three. So the term rule-based classification can be used to refer for any classification. Okay, any type of classification we can use rule-based classification, but for that we have to make if-then rules. If-then rules for the class prediction, to predict about the class levels, we have to use if-then rule. So we can write this if-then rule in the following form. We have to write if, then we will write condition, then keyword then, and conclusion. So here if and then, they are the keywords. These are the keywords we are using here. So in the condition we will see what is in the decision tree. If we are taking decision tree, any type of classifier we are taking, so for that we will use the condition for that, and the conclusion will have the prediction about the class level, right? Sometimes we are using and operator, and or also in the rule-based, in the rules we are writing for rule-based classifier. So if let us consider a rule is there, R1. So R1 is having if age is equal to youth, and here and operator is there, and student is equal to yes, then keyword by computer is equal to S. So this is a rule. Basically, the rule-based classifier classify the records of records by using a collection of if-then rules. So they are having the if-then rules collection. So if condition will be there, that on the basis of that we will get the class level. So the rule, in the rule, the condition will be there. After that, we are going to predict about the y. Y is nothing but that is the class level we are going to predict, right? So condition is the conjunction of attribute. That is a conjunction of attribute. We are writing that will be the syntax, right? And in the left hand side, while we are going to write the rule, some of the rules in the example we have seen. So in the left hand side, there will be the rule antecedent. We can also call as a precondition, that the condition we know, the attributes we know, on the basis of that we are going to write the syntax, going to write the rule. And the right hand side, there will be the rule consequent. So if there is a rule that R is equal to R1 or R2 or RK. So these are the some rules that are combined together, or with R, that is combined. So for example, if one example is there that is based on the birds and mammals. So on the basis of that table, the rule is there: blood type is equal to warm, and lays eggs is equal to S. So or the blood type is equal to warm or lay eggs is equal to S. That is classify that is in at the class level birds, right? So the blood will be warm, and the species is going to lay the egg, so that will be the bird. The class will be the bird. Another example is there: taxable income is less than 50,000 and refund is equal to yes. So that is a symbol S, and no, or, and or, that is a and, that is a or. So refund is equal to S, so that the classifier will classify in at the evade is equal to no. So class will be no, right? So these were the few syntaxes written, if then rules were written there. So the if part of any rule will be known as a rule antecedent. Or we can say that is precondition, and then part will be the rule consequent. Now, so that is the points to remember that I have said. Left hand side will be the rule antecedent, and right hand side will be the rule consequent. There will be the consequent. There will be the coverage. Coverage will be there for any of the rules. So what is coverage? Coverage is fraction of records that is going to satisfy the antecedent of rule. That is going to satisfy, then only that will be the coverage of that is covering the rule, right? What is the accuracy of that rule? The fraction of records that is having both of the antecedent and consequent for the rule. So in that, for the particular rule, both of the condition will be there, that is satisfying the antecedent and consequent for the particular rule. Now, so if the rule antecedent, the condition consists of one or more. If there is a condition, if more than one attribute tests are there, so if we will write such as age is equal to youth, and that is combining with and student is equal to S. So that will be added with the logically ANDed operator. So AND operator will be there to add two of the attribute tests. So the rules consequent will be that is containing the class prediction. So in the right hand side there will be the class predictor, class prediction, class level will be there. So that will be written as R1, that is a R1 rule, age is equal to youth, that is, and the student is equal to S. So that is classify the boy computer no. So he is going to buy the computer. If the condition in rule antecedent holds true, if that will be true for the given information at tuple, so that we can say that rule antecedent will be satisfied. That is true means satisfied. All the rules will be the records is matching with that rules. The particular records decision tree somewhat tests are there that is satisfying that particular rule, and the rule is covering all the tuple, all the table, all the record. Now, so a rule R can be accessed by its coverage. So we have to measure the coverage and as well as the accuracy of the rule that has been written. So if there is a tuple D, if there is a tuple X, so from a class level, the class level data set is there D, the data set is there, that is called as D, the rule is R is the rule, and the tuple is X. The tuple is, we're calling it as X. So what will be there? The n covers will be there. So n covers will be the number of tuples that is going to cover by R, that is particular rule. So that will be the n cover. N correct, what will be the n correct? The number of tuples that is correctly labeled by correctly classified by the same rule, same rule that is written in that line. And the mod of D, that will be the number of tuples in that particular data set. The data set is D. So how we can, what is the formula of the accuracy and coverage? So we can define the coverage and accuracy of that particular rule R as the coverage of R is equal to N covers, that is number of tuples covered by R, number of tuples that is having in R, that is covering the rule, and that is divided by mod D, that is the number of what are the different information is there in that data set. And what will be the accuracy of the rule? The accuracy of the rule will be the N covers divided by N correct. So N cover is nothing but that is number of tuples in R, number of tuples in R, number of information in R, that will be divided by the what is the number of tuples correctly labeled, correctly classified by R. The number of tuples classified by that particular rule R. So by these two of the formula we are going to achieve the coverage and accuracy. Now, so this is in this figure we can see this is the table that is having the rule content. What are the rules we have written in earlier slide? So in this table we are having the those class levels RID age, we are having income, student, credit rating, and class. That is on the basis of that the class is going to be classified. The class level is as class Y computer. So that is having the 14 records, and the class is having the S and No. Two types of class levels are there. So the consider rule R1 is there, that is having to cover the two of these tuples. These are having 14 tuples, 14 records, but the rule that we had written in earlier example, that is going to cover only two of the tuples. So how we can see? We will see. So that was basically the all electronics consumer database. From there we have taken this particular table. So if we are going to write the rule for that, the R1 is equal to age is equal to youth, that negates student is equal to yes, that is going to classify the by computer is equal to S. So this rule from where it has been taken, only two of the tuples. We will see that age is equal to youth. This student is also there. Student is S, right? And that is going to classify the S. So the 9 number of tuple that has been taken from there. And other we will check if youth is equal to age is equal to youth. This if age is equal to youth and the student is there, the student having that information, that is going to classify as the by computer, that is going to buy the computer. So those of the two tuples has been written by these rules. Okay? So how we can know about the accuracy and coverage about that? There were the rule. So there was the formula. The coverage R1 is equal to the two of the tuples has been covered apart from 14. So 2 divided by 14. So we are getting the 14.28% coverage of that rule. So which are this percentage of the part it is covering in the rule. How we are getting the accuracy from the formula? The formula is accuracy is equal to, that is the number of tuples in R divided by number of classified tuples in that particular data set. So that is having the 2, because both are 2, that is because 2 are covering only and 2 are there only. So 2 divided by 2, that is accuracy is 100%. So that the rule is covering those 2 tuples, that is covering all of the information in particular line. So we have achieved the coverage and accuracy from this example. Now let's see how we can use the rule based classification to predict the class level of given tuple if the given tuple is x. So if a rule is satisfied by x, suppose the given tuple is x and rule is going to satisfy in the earlier example we have seen, so the rule is said to be triggered. So there is a term we will call that rule is triggered. So for example, suppose we have x is equal to age is equal to youth, income is equal to medium, student is equal to yes, and credit rating is equal to fair. So in this line that is going to satisfy the tuple that is having all of the four information and that particular one record. So the rule has been satisfied. So that we will call as that is the rule has triggered. That the rule has triggered. So we would like to classify according to the by computer label. Class label is there. So X satisfy the R1. X is going to satisfy that particular rule R1. So which is going to trigger the rule. So we will say that particular line like this. So if the class X is there, class tuple that is going to by the computer, the rule is that is going to satisfy. So we will call as the rule is going to trigger the rule. So if rule is the only rule satisfy, if that particular rule will be the only because if their other rule will not be satisfied, then the rule fires by the returning the class prediction of the same class tuple. So the same given tuple. So that if that will be satisfied, then only it is going to be considered. Otherwise, if that is not other rules will not be satisfied, the other rules will be fired. That would not be considered. So the triggering is nothing that we are calling that the rule is satisfying, right? So triggering that is having the property that does not always mean that firing, because there may be more than one rule that is going to satisfy. So that will always not be true. Some of the time it will be untrue. So if more than one rule will be triggered, then if we are going to the classifier is going to classify for a different class level, we will see. So we need a conflict for that because two of the classes will be there, class levels will be there. Because of that rule, there would be many of the class levels. So if that is going to not that is not going to satisfy, so many class levels records will be there. So for that we need to conflict the resolution strategy. So we need conflict resolution strategy to figure out which of the rule is going to get the fire. What are the rules we need to fire, and we are going to assign its prediction to class tuple var X. So the size ordering scheme will be there. So that is nothing but one conflict resolution strategy is there, that is called as a size ordering scheme. So that is going to assign the highest priority to the triggering rule. So the triggering rule only will be considered as a highest priority. So that because that is having in that term that is having the toughest requirement. So the toughest requirement we will see, but we have to know about what are the highest priority will be there. So toughness will be there. So toughness is one term that is having while we are considering that is a highest priority. So toughness will be measured by the rule antecedent size. So what will be the size of the left hand side rule? So on the basis of that only we are going to decide how tough that rule is. What is the toughness of that rule? So that is the triggering rule, which is with the most attribute test will be fired. So on the basis of that, the test will be fired. So now the rule ordering scheme that is going to prioritize, that is going to take the rule beforehand. So the ordering may be the class based on the class will be there, the ordering will be there on the basis of class as well as on the rule based. So that will be taken by that rule ordering scheme. So if the class based ordering will be there, because these are the two types of schemes. These are the two types of rule ordering scheme. First is class based and second is the rule based. If rule based will be there, the classes will be sorted in order to decreasing importance. So in order to decreasing, the classes will be that will be classified as that will be sorted as a decreasing order. That is going to decrease the order of prevalence, right? And that is all. If that will be there, all of the rules for the most prevent. What is prevent? Most frequent. What is going to occur? The most frequent class level will be there. So the class. When the most prevent class rule comes, the class comes first, then the rule will be the next prevalent class, and then so on. So like this we have to write. So the most frequent class will be first, then second, then third. Like this we have to write. So within each class, the rules will not be ordered. They don't have to be, because they all is going to predict about the same class. That they are of the same class. If S is class, so they are all having the S type of class. So, and there cannot be any class conflict, because that is the rule will not be ordered. So there could have many types of same class levels. Now, so if there will be the rule based ordering, we have seen the class based ordering. Now we will see when there will be the rule based ordering. So the rules will be organized into one long priority list. So one list will be there, and that will be prioritized according to the same measure of rule quality. That is on the basis of some of the measures are there. On the basis of that only the priority will be there, and that will be sorted in that priority list. So what will be there? Accuracy. On the basis of accuracy, coverage, size are based on the advice from the domain expert. So on the basis of that, the rule based ordering will be taken care. So in that long priority list. So like that we have to going to order the particular rule. So when the rule ordering will be used, the rule ordering is going to be used. The rule set will be known as a decision list. So that long priority list will be called as a decision list. With the rule ordering, the triggering rule that is going to be taken, that will be earliest in the list. That is going to be high. That is having the highest priority, and so it is going to do the prediction about that particular class level. So the first highest priority will be there. So that is going to classify that particular class level. So apart from these, the highest any other rules can also satisfy the detectable, but that will be ignored from that. So in the base on the basis of this important terminology, if any other rules will be there, that will be excluded, that will be removed. So most of the rule based classification system, that is using the class based rule ordering. So we are not using the rule based ordering particularly because there will be the long queue. For each of the time we have to do for each iteration we have to know about what is the accuracy, coverage and size. So we are going to use the class based ordering. So if there will be no rules that is going to be satisfied for that particular, so how we are going to determine how we are going to get the class level for that particular record. In this case, we are going to call as a fallback. We are going to write it as a default rule. So that can be written as that can be specified as a default class on the basis of what we are having that training set. So what are the records we are having, on the basis of that we can write the default rules. So if that any other rules are not satisfying, this may be the class in majority. majority can be there, the majority class of the tuple that will be there, so that would not be covered by that particular rule. So we are not going to write those of that in that particular rule we are going to write. So the default rule will be evaluated at the end. That is going to be evaluated. We have to check if it is correct or not. So if and only if the other rule is going to satisfy the data tuple. So other rule is also considering, that is having all the data information in that particular rule. Then only we are going to say that default rule is there. That is the correct default rule we have written. The condition in the default rule that can be empty. In this way, the rule has been going to be fired from, because there would not be other rule they are going to satisfy the particular rule. So on the basis of this only we are going to say that. So the decision tree. Now we are going to write how we are going to rule extraction for the decision tree. So the decision tree can become the large and difficult to interpret. While we are going to classify, we are going to use the rule based classifier. The decision tree can be large in size. So in that condition, we are going to write the if else rules for that. The rule based classifier we are going to use, because that will be the very, very we can say easy. So on the basis of the that particular rule, we are going to say that will be easy to understand actually. So in comparison with the decision tree, the if else rule may be that can be easier, what I have said, for the humans to understand. So who they don't know about the what are the records are there. If their naive is there, naive user is there, the end user is there, they don't know about what are the particular records are there, what are the class levels are there. So on the basis of the rule only, we are going to know about what are the class levels are there. So particularly if the data, that particular decision tree will be large, then only we are going to write. So that will be easy to understand. To extract the rules from the decision tree, we have one rule will be created for the each path, and then that will be followed from the root to leaf node. So from the root node to leaf node, we have to write the decision rule. So each of the splitting, we can say leaf will be there. So for that, from which of the particular leaf that is going to be split. So for that, the criteria is there. So that is having the given path, and that will be conjuncted with the AND operator. So that will be ANDed from the rule antecedent that is having in the if part. So in the left hand side, what are the conditions will be there. So on the basis of that only, we are going to split that particular branches from that particular root node. We can say internal node, right? So the leaf node. Now we are going to the leaf node. So the leaf node that is going to hold about the class prediction. So on the leaf node, all the class level will be classified. That will be right. That will be, we can know about only seeing the leaf node. We can tell what are the class levels are there. So that is having the class prediction and forming the rule consequent then part. So that is having the basically, because we are going to predict about the class level, and that part that in leaf node that is having. Now, so this is a figure that is having the same we can say rule we have written earlier on the basis of that table. So that is having the suppose the student is having the age, and student is youth and middle aged and senior, right? So if the student that is classified in yes, student is in no, so that will be the class level will be no. That is classified in yes, it will be the class level will be S. So like this, the particular figure is there. So on the basis of that, we can write some of the rules. So if for one rule, if R1 is there, one rule is there. If age is equal to youth, if age is youth and student is no, right? Age is youth and student is no, so that by computer is equal to, that will be classified as no. So from this particular we can say decision tree, we can know about the what are the different class levels are there. That is easy to understand actually. The second, like this only, age is equal to youth and student is equal to yes. For this particular branch, that will be classified as S. He is going to buy the computer. Like this, the middle age will be there. If age is equal to middle age, then it is going to buy the computer. The student is buy the computer. The for the R4 rule, the fourth rule, if age is equal to senior, if credit rating is fair and credit rating is fair, that is he is not going to buy the computer. So like this, if that is senior excellent, that is going to buy the computer. So this is the easy to understand process and rules for decision tree. We can, for the larger decision tree, we can write the rule and we can understand easily. Now, so a disjunction, what were there, the logical or can be there. So that is why we are using that, because that is telling the each of the extracted rules are there. So if two of the rules has been written in between, the logical or will be there, then we will call as each of the extracted rules are there. So because the rules are extracted directly from the tree, so that will be the mutually exclusive as well as the exhaustive. So there are two terms, very important terms. We should know about that. So the what is mutually exclusive? That means the we cannot have rules that conflicts, but because no two of the rules is going to trigger the same tuple. So if there is the tuple, there is some record and there is two rules has been written and that is not going to be satisfied as well as triggered. So that will not be, that we will call as a mutually exclusive. What is exhaustive here? So there will be there is one rule for each of the possible attribute value combination, so that this set of rules did not require a different rule. So on the basis of that only the rule has will be written. So therefore the order of rules that does not matter. The what will be the order that can be unordered also. So, when the mutually exclusive and exhaustive will be there, so order of rules cannot be taken for the ordering. That will be unordering. So the rules extracted from the decision tree, what are the rules has been written, that is going to some of the times repeat, that is going to suffer from, that can be repeated, that can be replicated. So those of the two problems can be there at the large scale, that can be difficult to understand, to follow. So if those of the two problems will be there, we have although we can also easily understand the rules from the decision tree, because that is a pictorial representation, and if we are not having we are having the large tables, large data sets. So how to understand? On the basis of that only, that representation we are going to tell about the particular rules, and on the basis of rules we are going to tell about the what are the class levels are there. So that is easy to extract the rules from there, and we cannot need the same problem, same of the rules. We don't have to write the same of the work for the that rule, particular rule. So what we will do, if there is a repetition and a replication of the same tuple, same data set, same class level is there, so we have to prune that data. We have to remove that particular we can say branch from there. We will see if we are going to prune that. So for a given, if there is a rule antecedent, so any condition that does not improve the estimated accuracy. So for the rule ordering, we are going to know about. We are going to we are going to take the accuracy. We are going to take the accuracy. So accuracy of the rules can be pruned. that from the on the basis of that we can remove that particular branch. So therefore we can generalize that particular rule. So on the basis of that rule can be generalized. So the C 4.5 type of decision tree is there. So that is going to extract the rules from any of the unpruned tree, and then it is going to prune the rules from the that is going to use the pessimative approach. So pessimative approach, some of the other approaches are there, that is true pruning methods are there. On the basis of that, the C 4.5 decision tree that is going to extract the rules from the unpruned tree also. So that is the benefit of the C 4.5. If there is a repetition and replication of the same, we can say data tuples. So other problems can also be there. There were two problems we have seen. Other problems can be during the rule pruning. If you are going to remove the rule, so however, as the rules will not be going to mutually exclusive, we can say exhaustive. So on the basis of that, we are not going to take that particular rule. So for that conflict resolution, we are going to adopt the C 4.5 decision tree. So that is going to adopt that class level class based ordering scheme. So what we have used earlier, so it is going to group all the rules, and that is going to be combined in a single class. So for that we have to determine the ranking of these classes of the rules. So the C4 find it is that is going to use that as the particular rules, that is going to use the class based ordering. So within a rule set, we can say the rules will not be ordered. If that will be not ordered, so C 4.5 is going to order the class rule. There is a one we can say one classification, one property is there of the C 4.5 decision tree that is going to classify that is going to order the class rules, and so as it is also going to minimize the number of positive errors. So false positive errors it is going to classify. So on the basis of that class rule set, that what will be there, the least number of false positive will be come first, that will be taken first into that particular route. So that was all about decision tree. So we have used the rule based classifier. What are the advantages we are going to use? If we are using the rule based classifier, what are the advantages are there? So as we can say, highly expressive decision tree will be there, because that is a graphical representation. So that will be easy to interpret. We can easily interpret. We can easily going to generate the rules from there. We can classify new of the examples easily from that particular decision tree, and the performance can also be better than the other decision tree. So this other of the classifiers. So that on the basis of the rule based classifier, we are easily going to understand the classification of that particular class levels. So that was all about today's class. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.